Greetings. We are Team GG, consisting of Ali Taqi, Amr Al-Khatib, Tal Yasin, and Tamal Mayan. Together, we present to you our project, KINAD. For many educational institutions, delivering information to students has always been a difficult aspect in learning, as there are different types of learning methods such as visual, auditory, and kinesthetic. The kinesthetic learning method has shown to be the most effective in absorbing information. When students interact with the learning material, it improves the efficiency of learning and memorizing that material. While there can be interactions with various types of science experiments, subjects such as English and mathematics are lacking the same type of interaction. This impacts both the education system and ultimately the students. Our solution helps take care of this problem by adding an element of interactivity between the students and the learning material that enhances kinesthetic learning. KINAD is a platform that provides students with a variety of different mini-games and learning tools for different subjects in a way that encourages human interactions with the material to be learned. It also encourages contribution from students to enhance the games and applets by making their own levels or maps for the applets. Our solution relies on expanding kinesthetic learning by using a motion sensing input device, specifically the Microsoft Kinect, to interact with the educational programs and games. This is made possible with our software, KINAD. Our software improves learning activities by adding human interaction with the learning material. KINAD is designed in a way that would encourage peer contribution with other users to further improve learning and increase the challenge. It is designed for children and young teenagers, so the interface is made completely user-friendly so that a user can start playing immediately. Users are given feedback for their performance on games and applets. With the technology of Microsoft Kinect, we are able to simulate scientific lab experiments. Having labs in a virtual environment means that you do not need high costs that come with buying the lab equipments. There are also no hazards associated with the experiments such as toxins and inflammatory substances. And last but not least, there isn't a need for sacrificing the lives of insects and animals to do the biology labs anymore. With this solution, we have found a new way to use existing technology which largely impacts the end user by providing kinesthetic learners a new way to learn. The audience in our solution is students, specifically kinesthetic learners, and this solution will make a big difference. It is notable that our solution does not entirely solve the problem, but alleviates it. The architecture of our solution consists of 5 components: the user, Kinect, our software and internet connection, and our database. The user acts as our main input. The Kinect translates the input data for the software, and the software views the data. From this, it can be concluded that we are following the model view controller architecture. Here you can see the flow and usage of data in our application. The Microsoft Kinect would take the user skeleton as the input, which feeds the data to our software. The software is connected to the internet to send and retrieve data from our database. Our design is easy to test because the database is optional in the process, given that the games are already downloaded on the computer. We built the solution with scalability in mind. Our platform allows the creation of new games and also the expansion of existing ones. For the business viability, we are planning a 1-month trial of our system for students. The students' age have to be in the range of 6 to 15. The software assumes you already have a Kinect with a computer. The cost of the software after the trial would be around $99. The target will be the Kuwaiti market, and we will use social media to advertise for the trial. During our testing and trials, several of the user feedback suggested that we make use of the Kinect voice recognition feature. Therefore, we are working towards adding voice commands to our platform. In the end, what we're creating reflects the old methods of fun learning when we were kids. We've come a long way from puzzles and Lego to providing virtual environments and interactivity. With this era of technology, we can place ourselves in a virtual world and learn so much with a device that can steer our imagination in different ways. KINAD is the future of learning. Thank you.